Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Aiman bin Burhan. I will present to you about solid mechanics, is force and factor of safety analysis from actual structure. So my members in my group is Arman Hushairi bin Aswani, Muhammad Irfan Daniel bin Hizaini, and Nom Nadiha binti Yusri Fauzi Menin. Next. So the introduction is the purpose of the subject is to identify the force and factor of safety for the selected structure. So the objective is to draw detailed force body diagram from the structure and to develop equilibrium equation from the force body diagram, to analysis force member from the structure, and to determine the factor of safety for the structure based on the allowable force.
Assalamualaikum and good day. I'm Irfan Daniel and I'm going to explain about the systems involved in this project. So the theory involved is the moment of force, thrust and frame, and also equilibrium of force. Next slide. So as you can see on the right, it is the actual structure for our project, and we are taking the MOS speaker tower. And on the left side, you can see the free body diagram and the measurement assumed for the speaker tower and the force acted on the speaker tower, as you can see, and the support reaction on the bottom. Okay, next slide. I pass to the next member.
Okay, Assalamualaikum. My name is Nur Najiha. So I will explain about the calculations of finding the force acting on each member. So before we do the calculation, we assume that the weight of the speaker cage is 101.94 kilo, which is 1000 Newton. And the second is force acting on each leg, which is 250 Newton per leg per each member. And the state is 210 gigapascal, and the rod of diameter is 5.98 millimeter. Okay, for the calculation, we start with the point G. This calculation is based on the force body diagram. So we start from point G, looking for force acting on G E member and force at G F member. So at G E member is negative 250 Newton, and for force at G F member is 0 Newton. And we proceed with point H and point E, looking for each member, force at each member. Next. And we proceed for point C, point D, and point A. So for point C, we got force at CA, which is 250 Newton, and CD, which is 0. At point D, FDB, which is 250 Newton, and FAD, which is 0. So we find the moment on A, and we got BY at 250 Newton, and we do summations of Fx and Fy. We got Ax and Ax is equal to Bs and equal to 0, and Ay is equal to 250 Newton. Ax and Bs are the zero force member. So we do the assumptions of the weights of the speaker cage, which is 101.94 kilo. So next. I will pass this presentation to Arman Kushairi.
Assalamualaikum, I am Arman Kushairi. So I will explain about the factor of safety. So a factor of safety is a factor that normally been accounted to ensure the structural designing that been created will be safe from any event of unexpected failure or deformation from being happen. This is also to fulfill the aspect of safety equipment and fall protection, which is extremely important. Therefore, it is important because if a designing structural fails after it been made, the cost of it to redo the structure will increase, and also injury or event death will risk as well as the company financial loss. So factor of safety must be more than one. FOS must be more than one. So for the calculation, so factor of safety equal to ultimate stress over by allowable stress. Assume ultimate stress is 0.30 MPa and allowable stress are been calculated for 0.25 MPa. So ultimate stress 0.30 MPa divided by allowable stress that is 0.25 MPa, we get FOS, which is the factor of safety for 1.2. So 1.2 is larger than 1. So I pass to the next member.
Okay, for the conclusion of the assignment is the factor of the safety must be larger than 1 to avoid potential failure of the member. However, the actual value will depend on the type of material used and the potential application of member. The purpose of the finding factor of the safety is to reduce the risk of any failure and increase the safety of the people. So that's all for my group teammate. Assalamualaikum warahmatullahi taala wabarakatuh. Thank you.